Welcome back. So you made your list, and now I'll share mine. I'm going to use three shapes. I'm going to use a rectangle for strategies, an oval for big ideas, and a triangle for models. So let's start at the beginning. Early on, when children are trying to mathematize or model a multiplication problem, a problem that you and I would say calls for multiplication, they will often draw a picture or use tallies. In this unit, you may even find them drawing candy boxes and counting every square. They count 3 times. They represent the group, check that they have all the groups, that they have all the objects in the group, and then they count from the beginning all over again. But that quickly usually moves on to skip counting and repeated addition. So you are likely to see a lot of repeated addition strategies early on. You may also see children putting some of the repeated additions together, making groups together and counting larger groups. I like calling that groups can be regrouped, and that is a huge, big idea. Even the idea of understanding that groups can be counted with the same words as we use when we count, for example, by ones, objects in a group, is a big idea for children. Huge. They think of 3 5s as the 3 being a number that is actually counting the number of groups, whereas the 5 is actually counting the number of objects in a group, making the group a unit to count. We call unitizing, and that's a big idea. But to deeply understand the relationship between multiplication and division, children have to invent the idea that all of these groups within the whole add up to the whole. And therefore, if you know the size of the group and you want to find out how many groups fit, then skip counting by the number in the group may be a strategy they try for early division as well. In fact, you may see a lot of that in the beginning of this unit. But now let's go further in the landscape. Where do we want to take the children? What kind of a journey are we hoping to take them on? After they invent the idea that groups can be regrouped to make all of this repeated addition easier, we start seeing the emergence of some much more powerful strategies. For example, they double. And then when they put 2 groups together and they realize they only need half as many groups. So this emerges a strategy of doubling and halving, which can also become tripling and thirding. So if we want to find 5 4s, that's the same thing as 10 2s. If you want to find 9 6s, that is the same thing as 3 times 18. These kinds of strategies will start evolving, and this generalizes into another big idea of the associative property, because really what's going on in doubling and halving is that the factor of 2 is just being reassociated. It may be with one factor first, and then we shift it over to the other factor, and so the first factor then got halved. Another track that we often see children take is the use of 10 times. And so as they start, they employ the use of facts they know, and we start seeing partial products evolving. If they want to find out 14 times 5, they might do 10 times 5, and then 4 times 5. And the big idea related to partial products is the distributive property. We also see proportional reasoning evolving. If they know that 2 10s is 20, then 4 10s is double it. It's 40. 8 tens would be double the 4 tens. We can play with ratios on a ratio model, with proportional reasoning being the big idea. Let's go back now to take a look at some of the other models that are important. In this unit, the array model is critical. It's being developed. It's being developed because it's going to be a powerful model to represent partial products, the commutative property. We don't have that one on our landscape yet. Let's get that one down. The idea that why is it that when you multiply by 10, you can put a 0 on the end, often comes up in relation to the commutative property, because that's 10 5s equaling 5 10s. The 0 goes down because the 5 is bumped over into the tens place. Children start noticing what they often will call the turnaround with the array, and the idea of the commutative property that 5 4s equals 4 5s can be explored with that model as well. So the array model is going to be critical. Way down the bottom of the landscape, when children are doing a lot of repeated addition, they often want to keep track of their repeated addition or their skip counting with a model, and the open number line model can be very powerful to represent the jumps on. Now, this unit also brings in the connection between multiplication and division. So early in the unit, the children are investigating how many boxes of 10 Muffles needs. And this, of course, is really, you and I know, division by 10. As children are solving it, they may not be thinking of it as division by 10. They're just trying to figure out how many boxes of 10 are needed for 218 truffles. But as they work on this investigation, they also begin to notice the patterns of multiplication by 10 and division by 10, the place value patterns that occur. The commutative property is the big idea related to why those patterns are occurring.